mitigation strategies, how we can prevent cross-site scripting, input validation as usual, if you get garbage in, garbage out, right? So input validation, whitelist approach. That means don't try to block every single attack. You better say, I'm just going to receive this specific type of information or even this specific list of input, nothing else. Can be alphanumeric, can be numeric, but only that, as I said, by type, by size, can be only 10 characters, 20 characters. It's very important. Output HTML coding for cross-site scripting is even the must have. You might miss input validation, but cross-site scripting is executed in the browser. That means every time you are writing something back to the browser, you need to do HTML encoding. What I mean is this. Instead of putting script, you have some APIs that will transform the less than and greater than into the HTML representation, which means the browser is not going to execute it as JavaScript code, but just as a string in the response. Recommended to use ESAPI, which is an API from OWASP, which supports multiple languages so that you can implement this solution across your different flavors. This is just an example of how you can implement it. And as usual, you can follow our labs to see this in great detail. Some APIs for you guys, some URL for you to visit it. And another suggestions, HTTP only cookie flag. That's a flag in the cookie. If you put it, the attacker cannot read your cookies via document.cookie. As you remember, the attacker was injecting an iframe with the document.cookie and is able to steal it. If we put this flag, JavaScript cannot read your document cookies. Is that easy? And that's the recommendation. Content security policy, very recommended. The guys from Chrome come up with this solution, and it's basically a set of headers that the server sends to the browser in order to say, hey, you need to comply with this in order to interact with other pages. Basically, it will protect your it will leverage the same origin policy. It can say something like this example. You know, the content security policy, it said you will connect to the default source, which is self, and the scripts can be loaded from self, which is the same origin, or the mysite.com. It's saying you can allow everything and scripts from the same origin and from mysite.com only, nothing else. You can control via HTTP headers the same origin policy, which means even if the attacker is able to bypass the browser implementation of the same origin, you still have this CSP policy to help you. For end users, you guys can use different plugins. I highly recommend NoScript from Firefox, which prevents most of the cross-site scripting attacks. Or if you're using Chrome, you can use ScriptSafe or uMatrix, which are other recommended ones too. Some references, definitely OWASP. Go to the cross-site scripting prevention sheet, which is very good for you guys to understand all the different techniques. CSP, if you want to learn more about it, it is there. Okay, guys, so just to summarizing, cross-site scripting is a high-risk vulnerability. You know why by this time. Easy to exploit and with a high impact to the organization. A PC from the organization can be forced to visit a specific URL, which can exploit your browser and get access right into your network. But it's also easy to prevent. It's a well-known attack and a well-known solution. Multiple mitigation techniques available. Another thing that we need to mention is that the browsers comes with built-in protection from cross-site, so make sure to not disable it. And if you can use CSP as described to help you to enforce the same origin and prevent other attacks. Secure code review is always recommended for you to find problems in your web applications, and penetration testing once it is in production. Hope you like it.